Hello wonderful person, this is Anton, and today we're going to be discussing some somewhat intriguing discoveries coming from a very bizarre and very ancient galaxy. The galaxy you see right here referred to as NGC 6889, a galaxy that shouldn't really be doing what it seems to be doing. But in order to understand why this discovery is so bizarre and why this is so unusual, let's actually discuss where this is happening first and what we know about these regions. And here we're actually talking about what's known as galactic voids. And so what exactly is this? Well, when it comes to the universe, we normally imagine this as this vast space filled with galaxies and various galactic superclusters that are essentially spread across the universe, sort of resembling a kind of a bright lit city, with all of this interacting, merging, and evolving over time. But the thing is, all of this is actually organized in a very specific way, forming what the researchers refer to as the cosmic web. These extremely long and interconnected strings of material that seem to stretch for millions of light years and basically form the entire universe. If we were to somehow zoom out, it might resemble something like this. And so as you can see, between these clusters and between all these galaxies, there seem to be regions of almost complete darkness. Vast, nearly empty regions of space that we normally refer to as either galactic voids or cosmic voids, with this map of some of the nearest voids showing us where they're located and what they kind of look like. And so as the name implies, these are essentially regions of almost entirely complete empty space. Not truly empty, but empty enough. And so with the universe organized in these gigantic web-like formations, the formations consisting of dense knots of galaxies and very long strands known as filaments, the empty areas between them are essentially these cosmic voids. And the ones known to us are actually vast. They're incredibly large in size, usually spanning anywhere from 30 to 300 million light years across, and are also growing in size over time. But once again, even though they seem empty, they're not truly empty. They just represent a much lower density compared to everything else, with the average density of 1/10 of what we usually find in other regions. And it just so happens that our own Milky Way is next to one of these areas, the region right here referred to as the local void. And today we're going to be discussing one of the galaxies that just happens to be inside one of these voids and has now been observed doing something that astronomers kind of didn't expect. Nothing dramatic, but something that does not make sense in terms of galactic evolution. And so once again we're discussing the object right here. And the reason this particular observation and this galaxy are so exciting is because NGC 6889 is actually right inside the local void, practically in the center. And that makes it a true void galaxy, which is the term used for occasional galaxy discovered in one of these regions. And it's actually a pretty small list. For example, for the local void that we discussed previously and that you can learn about in one of the previous videos, we only know of 5 galaxies here. But in reality, we don't even expect these regions to contain galaxies because there's just not enough stuff to form anything here. These are very isolated regions, rarely experiencing any interaction, and obviously experiencing no collisions and no mergers that would usually result in dense environments to form stars. As a matter of fact, for many years, scientists always predicted these void galaxies to be pristine examples of fossil galaxies, ancient galaxies from the beginning of the universe that have not really done much and have not changed much in the last 13 billion years. But turns out that loneliness does not necessarily mean inactivity. In other words, turns out that we might have been just a little bit incorrect. And so this is where we have our enigma of NGC 6789. And this galaxy has been known to us for quite some time, since 1883. It's one of the closest examples of what's known as the Blue Compact Dwarf Galaxy, or BCD, and is approximately 12 million light years away from us in the direction of the local void. And because of its initial appearance, scientists classify this as an irregular galaxy, or basically a galaxy without any specific shape, mostly because its core shows intense recent star formation activity, with the core then giving this galaxy a somewhat irregular look. But the key mystery here is really in the scale and the timing of the star formation activity. Approximately 4% of the galactic total stellar mass, which is approximately 100 million times the mass of the Sun, seems to have surprisingly formed in the last 600 million years. So basically pretty recent times when it comes to galaxies. And this recent vigorous burst of star formation is very surprising. It means that the galaxy is actually still active despite being super isolated. Which basically raises this very important question. Where exactly did it get all of this gas required for the star formation? And why exactly did it suddenly have this starburst activity that created all of these stars? And this is a mystery because normally we expect this to happen when there is a galactic collision or some kind of a major density change, that usually involves something falling into the galaxy or something disturbing the galaxy in some way. For example, as we've discussed previously for the Milky Way galaxy, one of the main reasons the Sun was formed was because approximately 5 billion years ago, there was actually a major collision with the dwarf galaxy that we discussed in some of the previous videos in the description that created a massive amounts of overdensities, which then started forming stars at an increased rate, with one of those stars being our home. And so most of these galactic evolution models usually rely on external events like collisions or various close encounters. And that's because we expect the gas in this case to be compressed by something in order to create overdensities that can then start forming various baby star clusters. And while none of this is expected from this galaxy, NGC 6789 is very far from any major neighbors and is inside a very quiet and very inactive region of a cosmic void. And so this was the main premise and the main discovery and also the main investigation behind this recent study by Ignacio Trujillo and the team you see here. Here, scientists wanted to solve this paradox. How can you have isolation and recent star formation in this somewhat well-known but also somewhat bizarre galaxy? And so astronomers needed to search for the faint, telltale signs of past activity in order to figure out what's happening. And specifically, they were looking for evidence of a recent minor merger or some kind of an interaction that could have supplied the necessary fuel. Because otherwise, it just means that our galactic models are completely incorrect. And well, it turns out that the recent deep optical imaging that was conducted by the 2-meter twin telescope, also known as TTT-3, may have actually seen something. Here, this was crucial because various standard surveys, like the Sloan Digital Sky survey that was used previously, only show us some of the brighter central regions and no actual detail. But the new observations provided us unprecedented depth, reaching surface brightness limits down to almost 30 magnitudes per square arc second. Or just to rephrase this, super sensitive brightness observations. And with this level of depth, astronomers could now see galactic structure much further than before, with these results being very striking. But striking because of what they did not find. First of all, the morphology was actually more or less undisturbed. The deep imaging confirmed that the galaxy's outer structures remain undisturbed with a much rather elliptical shape, as you can see right here, suggesting that the galaxy has not experienced major collisions for a very long time. They also found no tidal features, basically long tail-like formations that would usually be formed by some kind of a merger and would usually contain some kind of a remnant. And here's actually a perfect example of one of these events. This is from the recent observations from the Vera Rubin Observatory of a stellar stream discovered in a very famous galaxy that has never been seen before. We've talked about this in one of the recent videos in the description. But once again, in the Void galaxy, nothing like this was seen, and there was no tidal features anywhere. And on top of this, there was minimal debris. Researchers in this case were able to place a lower upper limit on the stellar mass that could potentially surround the galaxy as merged debris from some kind of a collision. Basically here it would require 10 million solar masses of pure gas to form these stars, yet the debris was only approximately 200,000 solar masses. And so the fact in this case was that the galaxy was very isolated, yet exhibited intense central star formation without any signs of any recent mergers, which implied that there might be some kind of a alternative mechanism at play. So something else had to fuel the starburst, and something that was not considered before. And well, right now, the only explanations we have are basically very hypothetical. But here's what scientists think might have happened. First, maybe the starburst was fueled by some kind of a residual gas already residing inside the galaxy that somehow, luckily, created an overdensity that then started forming stars. Now, this is obviously something that could happen, but because we are talking about 10 million solar masses of gas, and because all of this happened very suddenly, right now this would suggest some kind of a very bizarre and very fortunate event that just has never really been seen before. Alternatively, maybe, this starburst was produced by the recent inflow of material, pristine material, that was not coming from any galaxy or from any galactic cluster, but was actually coming from the void itself. Or basically, in this case, it once again confirms that these voids are not truly empty and do actually occasionally contain chunks of gas. And here the accretion scenario does have support from some of the previous studies on the galaxy's chemical makeup. This galaxy is known to be chemically homogeneous and relatively metal-poor, with the inflow of this pristine metal-poor gas possibly explaining the observed ratios of nitrogen to oxygen and the sudden star formation that seems to have happened. Or just to rephrase this, here's what scientists believe might have happened. When a galaxy accretes metal-poor gas, or basically gas that has not been processed by many generations of stars and has not experienced supernova, This process tends to dilute existing interstellar medium, and this dilution then causes overall oxygen abundance to drop much lower than expected for a galaxy of certain brightness. But it usually does not affect certain ratios, such as ratios of nitrogen to oxygen. And so here, if suddenly there was a lot of gas entering from the outside, it would essentially change the chemical makeup of the galaxy, but would produce a very specific signal with nitrogen and oxygen, which is exactly what we're observing here. And so this is the case of what the scientists believe might have been cold gas accretion from the cosmic void, which is now believed to be a viable way for certain galaxies, even galaxies in isolation, to grow and to evolve. Although here the implication is that this particular galaxy might also be relatively close to one of the galactic filaments from which all of this gas potentially came from. And specifically, this filament might not contain a lot of stars, but seems to contain quite a lot of gas. And normally in very dense and hot filaments found in high density regions, they do feed galaxies and make them grow in size, producing a lot of stars. And so in this case, voids may also contain some of these tenuous networks, but in this case, instead of stars, they just contain a lot of pristine gas. And intriguingly, not so long ago, another study based on the void galaxy VGS-12, and the study right here you can find in the description, provided certain complementary evidence to this hypothesis. And here, this galaxy is an unusual polar disk galaxy that's also found inside the void, but does contain slightly different structure, with its very large gas disk oriented perpendicularly to the central stellar disk. And the chemical analysis of this galaxy also discovered unusual observations of oxygen and a very high concentration of nitrogen to oxygen that once again implies some kind of a gas dilution, with the influx of gas coming from somewhere else and very likely being pristine and untouched from the beginning of the universe. On top of this, unlike the previous galaxy, VGS-12 also exhibits signs of some kind of a disturbance that potentially suggests a very recent accretion event, but in this case just involving huge amounts of gas coming from somewhere. And more importantly, because this gas is ionized by some of the stars in the galaxy, it actually becomes pretty easily visible. And so in this case we have a direct evidence of another void galaxy clearly interacting with some kind of a pristine gas that's even happening right now. And so VGS-12 provides us with extremely strong evidence for the ongoing cold gas accretion that seems to result in the production of stars in these very bizarre galaxies. And so these two recent studies show us something really important about galactic formation. It looks like galaxies don't need to rely on mergers and violent interactions in order to acquire new gas and form new stars. Because as these galaxies show us, we know that they seem to have no collisions, and the only signs of star formation we detect indicate that the gas came from somewhere entirely different and very likely arrived here in a kind of a steady flow coming from the surrounding void environment. Which means that these are definitely very unique galaxies and provide us with a kind of a window back in time. We're essentially seeing what might have happened billions of years ago when a lot of these early galaxies started forming. Because here we have pristine gas over 13 billion years in age, finally interacting with something inside a galaxy and finally forming stars. And that's because this gas has never been anywhere else and has just stayed in these cosmic voids for the past 13.8 billion years. And though some of the original predictions suggested that this mechanism has long been extinguished and only dominated galactic growth in the early universe, looks like that's not entirely the case. It still contributes to galactic growth today and seems to be the main way void galaxies potentially formed and evolved over time, which also explains one of the major mysteries about them. It wasn't actually clear why these galaxies very often appear kind of young compared to any counterparts in the vicinity. And that's because, well, they are very young. Or I guess in some sense you can think of them as delayed in their development. It took them approximately 13 billion years to finally start forming. And naturally this also is going to one day teach us more about these galactic voids and the overall structure of the universe itself. But right now for cosmology this is also important because it provides us with additional evidence for the overall structure of the universe and seems to support a lot of the observations we have about this unseen cosmic web that very often guides and shapes the destiny of galaxies around us. But we'll definitely come back and discuss this more in some of the future videos because this is just a super fascinating topic. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM it directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.